Alright, this screencast is for problem 9 on exam 1, and in this problem you're given a transfer function, and if you look at it, it would be a spring mass damper kind of problem. It doesn't explicitly say that, but that's what the transfer function form suggests, okay, because there's the k constant, the mass, and the constant b. Okay, you're going to apply a step of the form a u of t. U of t is the unit step function. We know that the mass is 25 kilograms, and you're supposed to find the parameters a, b, and k based on the fact that you know something about the step response. Okay, so in this particular case, the step response has a rise time of 0.8 seconds, a peak overshoot of 25%, and a final value of 0.4. Okay, so we can get started by looking at the rise time. We know that the form of the solution looks like h of s is some constant over s squared plus 2 zeta omega n s plus omega n squared. So if we can find equations that give us omega n and zeta, we can match coefficients on the polynomial of s squared and find the parameters that we need. Okay, so we look first at the rise time. So the rise time equal 0.8 tells us that omega n is 2.25. Since the mass is known, we can back out k and get a value for k. All right. Then we can apply the final value theorem. Okay, remember we're going to put in a step function of the form a u of t. So the Laplace transform of that would be a over s. Okay, so then we multiply h of s times x, and then use the final value theorem. We have s times y of s. Remember, this whole thing here is y of s. And let s go to 0. And when I do, I take that limit, I get a value of a over m. I'm sorry, a over k. The m's cancel. So I know that the final value is supposed to be 0.4, so a over k gives me 0.4. Since I already know k, I can then find a. Alright, so that just leaves us with the b term. Alright, and so from the overshoot, we can back out the parameter zeta. Once we have zeta, we know that 2 zeta omega n is b over m. I already know m, so I can back out b. Alright, so there's the solution for problem number 9.